It is 6:45 in the morning on April 2nd, 2026. The coastal city of Ternate is just waking up, resting quietly beneath its towering volcanic peaks. At that moment, the ground beneath these homes begins to pitch and roll, heaving with the violence of a small boat caught in a storm. A massive 7.4 magnitude earthquake is tearing through the region. The impact is immediate. In Manado, the Saloma hospital sustains critical structural damage and collapses. Power grids fail, plunging entire blocks into darkness as residents scramble into the streets in their pajamas. Tragically, a 70-year-old woman loses her life in the chaos. Seismic events are defined by this suddenness. In mere seconds, a routine morning transforms into a desperate fight for survival. While the destruction is visible on the surface, the true source of this energy sits 126 kilometers away. We look 35 kilometers beneath the Molucca Sea. Here, the crust fractures, releasing massive kinetic energy. This energy travels upward through solid rock, hits the ocean floor, and races outward as shockwaves, carrying intense vibrations to distant coastlines. The collapsed buildings and cracked roads are the final, visible stage of a massive geological failure hidden deep within the oceanic crust. When the seafloor shifts upward during an earthquake, it displaces the entire volume of water resting above it, creating a secondary hazard. Across the coast, tsunami warning sirens immediately start to blare. For 2 hours, coastal residents wait in suspense, watching the shoreline for an approaching surge. Eventually, the displaced water reaches the coast of North Minahasa. The recorded height of the resulting tsunami wave measures exactly 75 centimeters. This visual scale comparison demonstrates why a 75-centimeter measurement is deceptive. This volume of moving ocean water carries immense kinetic force. At this height, the mass is sufficient to overcome the weight and friction of a standard passenger vehicle, sweeping it away. The ocean acts as a threat multiplier, translating raw seismic shockwaves into a forceful, fluid movement. This pattern of activity raises a larger scientific question. Why does the Indonesian archipelago face such continuous seismic volatility? This map highlights a vast hidden network beneath the islands. Indonesia is situated directly atop a tectonic intersection. These segments represent 3 massive bodies of the Earth's crust: the Eurasian, Pacific, and Indo-Australian plates. These plates maintain a state of constant convergence, grinding against one another with immense force. Zooming out to a global scale, we see how this intersection connects to a much larger structure. This 40,000-kilometer boundary traces a horseshoe shape around the entire Pacific Ocean, the Ring of Fire. The scale of activity here is high. 90% of all global earthquakes take place along this specific boundary line. The Molucca Sea tremor follows the established pattern of this region. It is a recurring outcome of human life situated directly atop the world's most active geological engine. Back on the ground in Ternate, the danger continues long after the initial shake subsides. Within hours of the strike, over 50 aftershocks batter the region. This includes a 6.2 magnitude secondary quake, further destabilizing already weakened buildings. Looking at this presentation from Indonesia's disaster agency, the BNPB, we can see how they use intricate regional hazard maps to coordinate their response. They track shifting danger zones in real time, as emergency workers attempt rescues in compromised infrastructure. Disaster management in this zone requires emergency teams to perform rescues while the very ground they stand on continues to fracture. Because we cannot halt tectonic mechanics, our only defense is behavioral preparedness. If the Earth starts to move, the survival protocol is clear: drop, cover, and hold on. You must avoid the instinctual urge to flee. Never run while the ground is actively shaking, and stay away from windows or glass that could shatter. Human civilization exists at the mercy of the Earth's movements. Because we cannot control the ground beneath our feet, preparedness and a deep respect for nature's power remain our only viable survival strategy.